Hello everyone, welcome to today's seminar in the Smart Safety Connection series. My name is Wesley Mon and I'm the 2023 to 2024 Safety 21 Equity and Inclusion in Transportation Fellow. The Smart Safety Connection series is sponsored by Safety 21 as an opportunity for faculty to showcase their current transportation projects. It's also an opportunity for students, fellow faculty, deployment partners, and the broader community to engage and network with researchers, highlight opportunities for involvement, and foster future interdisciplinary collaboration. Please note this session is being recorded and all participants on Zoom have your mics muted. If you're on Zoom, feel free to send a message over in the chat whenever you feel, and our speaker will answer it at their earliest convenience. Now, to introduce said speaker. Sean Qian is a professor jointly appointed at CEE and Heinz College. He directs the Mobility Data Analytics Center at CMU, and his research interest lies in large-scale dynamic network modeling and large-scale data analytics for multimodal transportation systems, in development of intelligent transportation systems, and in understanding infrastructure systems interdependency. His research has been supported by a number of public agencies and private firms, such as the NSF, the DOE, DOT, PennDOT, Maryland Department of Transportation, IBM, Honda Research and Development, Fujitsu Inc., and amongst others. He serves on the AI committee of the ASCE and TRP and is a recipient of the NSF CAREER Award in 2018 and Greenshields Prize from the Transportation Research Board in 2017. He was a postdoctoral researcher in the Department of Civil and Environmental Engineering at Stanford University from 2011 to 2013 and received his PhD degree in civil engineering at the University of California, Davis in 2011 and his MS degree in statistics at Stanford University in 2012. So join me in welcoming our speaker today.
Thank you, everyone. Thank you for having me. As Wesley was speaking to my past experience, I feel very old enough to talk about a lot of unknowns. So today, I want to speak to a little bit about the safety work we did. Started probably a few years back, and I should also give credit to Jordan, who graduated already successfully, and he's the leading author. Now he works at Google, still doing the same causal analysis, but no longer with the work zones, but was kind of very interesting work that he did started a few years ago, and then so leads to a lot of very interesting conclusions to this work zone safety analysis. Also, Buju has been also involved in research, and right now, since Duran left, and we're carrying over the same kind of methodology, same work, but applied different. We're working now with different states, and the work started many years ago was based on PennDOT data, but we're trying to extend it to other states, particularly Maryland and California, and then Tao and Tessa, not here today. They're continuing the work, right? So when I say there's a lot of unknowns, I think the causal analysis is always extremely hard. A lot of things that I'm going to present today, this is more for internal discussions. You can feel free to jump in if you see any issues, or feel free to challenge me. But again, the safety is something we're really interested to know why. But oftentimes, because it's very complicated, there's a building environment, there's weather conditions, there are also different behavior in it. A lot of times, even though sometimes the statistic can make a lot of sense, but it simply just might not be the true cause of why the crash occurred. So therefore, many things I'm going to present today, including models, case studies, still are in progress. Some of the conclusion may not necessarily be final, so we can have more internal discussions as we go. Maybe leaving some time at the end of the talk. Okay. So why? Starting from why work zone safety analysis, why work zone safety is so critical. These are the numbers I took from 2018. I'm sure the number has been increasing over the years. I'm sure that during the COVID seasons and even after COVID, a lot of roads are still being renovated. It's actually our infrastructure in general is aging, so there's certainly you're going to see a lot of more work zones over time. Not just to build new infrastructure, but these are work zones that just to keep maintaining the road. So roughly you can see about, on peak seasons, roughly about 20% of the highways and national highway system in the US during peak construction seasons that we have this many, more than 3,000 work zones. And a crash occurred in work zone every 5 minutes. 2015, that's an old number. I'm sure the number only goes up a little bit over time. And the last one is really a tricky one. I can use it for motivation, but also I can use it just for sake of starting our discussion on why this is important to understand, right? So this is a quote from some of the work. 20 to 30% crash associated with work zones. When I say associated with work zones, this really means that you can see, I mean, the data tells us 20, 30% of the crash occurred during the time when the work zones are present, were present. But it doesn't necessarily mean that these crashes are entirely attributed to the presence of the work zone. I will tell you a lot of whole reasons why, because there could be it happens to be a heavy rainfall. It could be at the same time that you have the work zones, right? It could be heavy rainfall. It could be some reckless driving, someone speeding. There could be many different reasons, but only because the crash occurred at the same time where the work zone was a work zone was present. It also depends on the location, right? It could be happens to be within the work zone, but it could also be upstream work zone, downstream work zone. How do we know this is attributed to work zone? So it's a very, very complicated. So people are claiming significant portion of the crash are associated with work zone. This number itself needs to be carefully studied. So that kind of motivates the work that we're doing is that can we look at the data, can we really tell statistically how many of these work zones, these crash. Not only we want to know these are associated with work zone, but we want to know how many of them are truly caused, maybe at least partially attributed to the presence of work zone, and ideally know how these are related to work zone configurations, right? Different work zones have different strategies. We had work zone during the daytime that the work zone deployed at night. There are work zone super long. You want to open the work zone for days and weeks, or there are even 6 months and 2 years of work zone. So how does these different configuration will really make sense, or maybe it doesn't, right? So how does that relate to crash risks? So that's something we want to investigate and inform the data, not something they try to infer or just to make up. So the problem statement here is that we want to infer the causal relations among work zone configurations and highway crash. We are limiting our scopes to national highway system, freeway, highways, and then we want to look into how the length of work zone duration, time of day, right? You deployed during the daytime or nighttime, and also how is this related to traffic characteristics. There could be heavily main highways that carries 30,000 ADT versus you have only a rural road, still highway, but only carries a substantially and a small amount of traffic. And how does this work zone play a different role on these different type of roads? And so the last one is probably something that DOT will be very interested to build, is that for future references, right? Let's say we look at all the PennDOT 5 years of data, we identify, hey, under this condition X and Y, Z, work zones are more likely to cause increase the crash risks significantly. And what typically then, whenever you have this conclusion, you want to apply the results for future references. If the state DOT is trying to build a new additional work zone, proposing some new work zone next season, and they want to quantify the risks for futuristic work zones. And this is something the CMF is the crash modification factor, right? So there's a regular road, they have typical ways of estimating what's the chance of having crash. But now I'm deploying work zone, switching off of being on, and how does that increase? What percent? Let's say 20%, 30%, 50%, 100% increases of my crash risks. So this is the number that we also want to leverage this study to come up with, helping for future references. Again, we want to come up with some number to quantify the work zone risks. Okay, so and believe it or not, and a lot of states right now are looking to the CMF factor for different roadway settings. You know, if you have bike lane, if you have things like that, and any treatment to the roadway, there's a CMF factor associated with that. And then for work zone, we still don't have very clear picture of what number we should use. And I guess that is really based on case by case, and every state may have different work zone strategy, work zone deployment strategies. So that's also certainly going to be associated what work zone, what kind of work zone, where do you put the coins, what's a how often you want to put the coins, how far ahead you want to put the cones. So these are the work zone configurations that naturally built into, certainly is going to have an endogeneity about the work zone risks, right? So that's something we will discuss in more slides. So lastly, I think the problem is that a lot of the study understanding the causal or associational relationships or CMFs are based on very limited data set. Typically, if you look at the literature in the past, they probably have, we have a table showing all the relevant studies as if at least before 2020. Most of the study is based on tens of locations, hundreds at tops. So in this case, we want to leverage multi-year, high granular data. I'll explain a little bit more what the high granular mean in this case. There are more to talk about the granularity. But in general, we want to leverage many years for a complete set of data of work zones and speed, weather conditions in high granularity to truly understand the work zone impact. And this is what I think is a first of its kind study. Okay, so why this is challenging, right? And then clearly it's very important, and there's reason why we want to do it. But why this is challenging? And then there are, this whole crash analysis has been going on for decades, and people all have different approach. I think that all the approach has certain pros and cons, but this is probably the most sensible one in the past 10 years that people try to work with is called the before after. It's very straightforward. So you have work zone, and then this street A, you have work zone deployed for 6 months, and you want to measure before the work zone deployed it, and then you measure the total number crash, right? And then after work zone crash and deployed, and then you measure, hey, within the 6 months, what's the number of crash or near misses? Ideally, we still not getting a whole lot of near misses data yet. And then people can conclude, hey, the crash reduces or crash increases, and that's we can attribute that change in crash risks into work zones. But this is you can see this problem. This model is likely very highly biased because a lot of things can happen at the same time that you have work zone, right? So like I said before, if you happen to have, let's say you have 1 day of work zone, and you do see during this 1 day there is one crash. You can look at the year before, say 360 days, 5 days, there's 10 crash. And then the 10 can be normalized by 365 days, and while this 1 day work zone presence, they have one crash. Which one is work zone? Does work zone really increase the crash risks? In this case, if you only look at the before after analysis, yes, right? Because that the daily risk of having crash as you observe is higher. But then if we look into that specific day when work zone deployed, there a lot of things can happen. It could be that the day you have a heavy rainfall. It could be happens that day is the winter season, right? It happens the winter, maybe naturally people are more likely to get into a crash, depending on, of course, the local characteristics. It could also be the speeding. It could be when that single crash, because essentially crash is a rare event. So the fact that you see there's a crash, of course, there's a whole police report about why it's also very subjective reasoning why this crash occurred, but it could be speeding, right? And simply because someone was reckless driving, this person speeded a little bit, it turns out becomes and resulted in a crash. It could be, this person is texting and these are behavioral considerations, right? There is a lot of study looking at the longer time period of work zone. For example, if I look at the 2023 versus 2024, total, let's say year, 2020, no, we cannot get into 2024, but let's say 2022, there's no work zone. 2023, there's a 1 year work zone. And the thing is that people driving behavior could change, right? It seems like COVID, it could be such that, let's say January 1st, 2023 is the day that the COVID policy, everything's lifted. And certainly there's likely to have some kind of behavioral change of how people drive with or without COVID, especially if you look at the longer time period. So how do you rule out these driving behavior change that are related to crash? Again, everything can happen to be that on the same location, same time, but it doesn't necessarily mean it is a work zone. So we have to really rule out all the possibilities, right? Infrastructure, again, could be, some roads the pavement deteriorates over time, for example, and the year 2022 versus the year 2023, the pavement could deteriorate, highly deteriorated. So therefore, that potentially can cause more crash, only because you have potholes, right? And then after going through a very tough season. So that also should be considered. It don't have to entirely to be work zone. See, the tricky part is that it's correlated, because the more, imagine that now you have a lot of potholes, and then that causes more crash. But it turns out the fact that you have more potholes and you're more likely to have a work zone to fix it, right? And then which one comes first? And this is really complicated. Is it attributed to work zone, or is this attributed to potholes? So I think that with what I'm going to about to show you, and next few slides is sort of more statistical experiment design, where we're hoping to at least minimize that bias. By the way, this is what we call confounding bias. This really means a lot of factors that could be potentially related to the fact that you're having the work zone, right? As seeing the work zone as a treatment. The same time that you're having a lot of other factors that could potentially influencing your treatment, influencing the population that you're treating. So therefore, that adds a lot of complexity. That's why this is super challenging. Okay. Like I said, most of the study, as far as we have seen, focus on association analysis. They simply relate the work zone crash versus different type of road characteristics, such as ADT. And then you can see a lot of the paper come back with a very different, inconsistent results. Someone saying, hey, this nighttime work zone causes more crash, but someone saying, hey, it's actually not, it's actually improved. People are seeing less crash. So you can see these conclusions are very inconsistent. So we try to say, hey, look, if we can design the more rigorously designed experiment, can we get the conclusion settled, and then we'll probably come up with end up with very different conclusions. So I want to give you a couple examples just to kind of stimulate the thinking, why we're doing it. Well, you can see later on the experiment design is very simple. But before I present the framework, this is again, the economists that use it quite a lot. This is called RDD design, regression discontinuity design. I thought this could be a very perfect example to apply the methodology in here. But I think that just to give you a couple examples, we can think about why things could go wrong if we just do regular regression analysis, and things you can be very different. Okay, so example number one. This is typically 10 years ago, maybe 20 years ago, how people in general literature does it. Is think about you have 10,000 road segments, right? And then these are all the road segments that with the work zone presence. And then some year you try to each data point will be each row, which you throw into regression model. So the first row could be segment 1 with work zone. Of course, segment 1 comes with ADT, number of lanes, speed limit. Work zone also has some configuration numbers. So imagine that you have each row being one data point, right? And you have 10,000 such data points. You can throw into a regression model. It tells you something about whether you have observed for each of these rows, each of these segments, each of these years, how many work zone crash, whether you assume these crash that you have seen could be related to all the features that you build into each data set. So this could go wrong because you really don't have any control group, right? So you don't have anything, the same row segment without work zone to tell you a lot about what things might look like originally. So just cross-sectionally comparing the work zone and the crash risks is not a great idea. Does that make sense? So things could go wrong because you simply just don't know what the same segment at the same year without the work zone will look like, right? The second example is, think about this, right? So now I propose, say I have the same roadway segment, 2013, there's no work zone. In 2014, there's the same roadway segment, I have a work zone. And you can do the same thing for all the 10,000 road segments. And does this make things better? No, really, because I already talked about that whenever the same time that you have work zone presence, because it's relatively longer time period, a lot of things can happen. Plus the change in driving behavior, changing in the building environment, changing weather conditions, changing the people's speeding, that also could be contributing factors. So this is clearly not good as well. This is example 3. This is a bit tricky though. Sorry, I just made a slide last night. I need to reflect on myself as well. Let's read it through. We have, let's say you have 4-lane heavy traffic, right? High volume ADT with the shorter lane work zone versus the 3-lane light traffic condition highway with the most right lane closed for work zone. So if you were to run a regression model based on this data, you can see that ADT is a confounding factor, right? Why? Because the fact that you are only, because you know the 4-lane traffic is super heavy. Right? This is super heavy traffic volume, and you don't want to intervene the traffic as much. Because of that, because the ADT is high, so you decide that I'm not going to do a full-size work zone. I'm going to only do shorter lane work zone. And while the other one, because it's very light traffic, even though it's a highway, but it's a very light traffic, so I get to close 1 lane out of the 3 lanes. So I can do something about it, right? On the actual physical driving lanes. So the fact that you're having ADT factor in to make a decision initially about what kind of work zone you will deploy will impact whatever the outcome, in this case is crash risks already. So in this case, the ADT impacts your work zone decision, or ADT also, of course, impacts your crash risks as well, right? Because generally we'll see the more traffic using the road, the more likely you see crash. The crash is just that doesn't have to be entirely attributed to work zone, only because the work zone is there. So you can see these are clearly in this case, we might, or if we run the regression like this, without considering ADT as a confounding factor, so one might overestimate the crash risks. You're simply attributing everything to the work zone, but although a part of the crash risk should be attributed to the high traffic volume, but the work zone itself is already attributed, so somehow related to ADT, heavy traffic volume. So this is, you can see this is a lot of tricky the scenarios that we're just playing, right? We tried, before we even do the study, we think about all the possible ways that we can brainstorm about things can go wrong. This is just example number 4. Sorry, I want to go a bit faster, I think, which is okay. So I only have a couple more graphs to show you after this example. So this example number 4 is the overall work zone crash frequency at night was lower than work zone crash frequency during daytime. Let's say this is a conclusion you're seeing. Hey, typically in the nighttime you have a much light traffic. The fact that you see in the nighttime 6 hours, you probably see 1 work zone versus daytime you see 6 crash, right? Does that mean that we should move all our work zone to deploy all the work zones at nighttime? Is this right conclusion? Probably not, because a lot of time also related to how the work zone configuration is being done, because the fact that it's nighttime, you certainly deploy more technologies in work zone, right? So if it's nighttime, you sort of, there's a I think MUTCD menu, each state has certain menus asking the contractors to put out the flashing lights and what's the interval, the spatial intervals that you need to put the cones, and the lane closure, the buffer lanes has to be this long. So there's a lot of configuration requirements that associated with the choice of time of day already. So you cannot simply just play that, hey, I'm going to treat the road very different way in order to change the crash risk. There are also other things that you're treating for will have to change at the same time. So that's another kind of a counterintuitive. If we were to get this conclusion, then we just simply cannot conclude that we want to change work zone by time of day. That simply won't necessarily reduce the crash risk. As just that's the simple argument they try to make. So here's our solution, right? I only have one slide about the solution, which is I think it's pretty straightforward. And then, but the way we design this is say now, I'm going to try to minimize the bias, the changes from week to week. We only look at the short-term work zones. In this case, we only look at the work zone with less than a week, right? It could be hours, could be few days, but we're not really looking at long period of time. 6 months or 1 year work zone is something that we believe there's quite a lot of changes, behavioral changes that we cannot capture. So let's just focus on work zones that are less than 1 week, right? And what we do is we look at a few weeks before the work zone deployed, right? This is a shock. This is a treatment. When the time the road has been shocked with this treatment, and then we also look at the after, a few weeks after. In this case, we test the different scenarios. We started from 15 weeks, 7 weeks ahead. This is 1 week, and 7 weeks after. So we know this is with shock. This is no shock. This is no shock. And then what's nice about this is that you can almost reasonably assume, right, during this 15-week time period, at least when the work zone starts being deployed, but right before and right after, you would reasonably assume that all the behavioral change, all the behavioral changes are attributed to the work zone, because if it's temperature, if it's the road, say. Reconstructing the road that could be more curved, or the pavement deterioration. These factors can be minimized, right? There's unlikely have a big drastic changes in pavement conditions and the scenic views or on the side of the roads, or maybe there's a new building come up and then sort of change the vision of the driving behavior. So these things can be ruled out, or only because you look at the right before, right after the shock. So we also limiting our time into weeks. Therefore, these type of change in building environment, these changes in the driving behavior can be minimized as well. Of course, we also add a control to this whole shock. We're not saying that, hey, everything else that's attributed to work zone.
Yeah, I just have a question. So is the work zone considered as a binary variable, or do we actually consider the characteristics of the work zone? For instance, to what extent does the work zone block the original path? Because sometimes you only have a small area, or sometimes you may have a larger area which block the original path entirely.
Yes.
Do we differentiate that?
So in this case, work zone is just a zero. It's a switch. It's binary decision 0 or 1. I agree with you that whenever, depend on how work zone is being set up, there are sometimes work zone, because I think that's a program encoded into the different work zone configurations. If you see a big work zone, let's say it's a shorter work zone, or it's a 2-lane work zone. So that certainly have different changes into the vision. But again, that comes with the treatment itself. It's not something additional on top of the treatment. So if you have the treatment that blocking the vision, of the drivers that comes with the work zone. So you can see later on, we try the way we designed this is not try to aggregate all the data into the same data pool to run the regression. We actually set the subset of the data. Say we only look at the work zone switch, shock or without shock, for say a specific type of work zone within less than a mile long, for example, or this only shorter lane work zone, or versus regular 1-lane closure or 2-lane closure. So you can, the point being that we designed this, try to minimize the change within this 15 weeks time period, and with assuming you can reasonably assume the only change during this whole environment, weather condition, build natural environment, is the work zone shock. And then you try to separate the data into different configurations. You can try to categorize the data by saying, hey, this is a type 1 work zone, this is a type 2 work zone, this is road type C, and then you can run your experiment based on the subset of the data only, so they can tell, hey, this is a type 1, type 2, type A, yes, work zone switch, that's the effect, right? So that's the whole concept of it. But I think you can take a close look. I think this design potentially, I never say eliminate, but I think it's kind of minimize the possibility of having all the issues, the challenges that we have discussed in the first 4 examples. Okay, this is RD design, I'm skipping it. Another aspect I should also clarify is that, like I said, a lot of study only will look at the hundreds of tens of work zones. In this case, we're looking at more than 5,000 work zones from year 2015 to the year 2017. We still, we have the new research assistants in our lab, but we try to work on updating the data, using the most recent years of data, try to see if it's also kind of looking very interesting to see whether the work zone impact has changed over the years, right? Especially with the COVID, which is kind of interesting. I think that we all complain that people driving more aggressively after COVID, me included. So this is, again, so we use a lot of data, but the whole, the point of in trying to see the challenge is that typically they don't have access to a lot of data, so it's really limited to a small set of locations. And the other point I'm trying to make here, I think it's very critical, also makes our study stand out, is a lot of times people only use the speed limit as a control. But in this case, I think about the crash, right? If we attribute the crash somehow to a abnormal, atypical kind of speed, let's say, in general, this peak hour, this could be 25 miles per hour because it's very jammed. But it happens that the speed measurement that we have from INRIX, I don't want to get into the whole discussion how INRIX get the data, but this is a probe vehicle speed measurement. Is somehow the speed measurement becomes 30, which is very, very atypical during the same time of day, peak hours. That's usually an indication of either traffic is super light or some vehicle is driving more aggressively, right? So we're trying to build into, because we have the high granular data, INRIX give us every single minute, every single road segment, roughly about the 10th mile or quarter mile, and the highways are sometimes a half mile spatial intervals that we know at this granularity, that every single minute, what's the probe vehicle's average speed. So the speed measurement can also give us information rather than using the static time invariant speed limit measurement. So in this case, we use the truly observed mid-level granular, spatially granular speed data measurement. So that can also really account for some of the potential crash risks as well. Anyway, so in most of the study, they do not consider everything, but we try. Never say I don't think that we consider everything, but we do want to include a lot of different factors. But solution here is that you can see the RDD design that we did before we chop the data into 30 minutes period of time. So we also want to rule out any of the noises, the measurement from the speed measurement. So every 30 minutes is a data row that enter and throw into our regression model. So that also, I think it does a pretty, we did some robustness check. You can try to chop the data into 15 minutes, 10 minutes, 30 minutes, 20 minutes, and 1 hour, whichever way of data. The results are relatively robust. That's why we're pretty confident about the outcomes. But the bottom line, we are doing everything based on 30 minutes, and then we use truly observed index data rather than using the speed limit, which doesn't really tell you anything about what's really happening on the scene, right? At the scene. You can see this is it's a lot of data we use. It's crash data, roadway data, PennDOT incident data feed, INRIX data, TomTom, which is also tell you a little about the geography of the road segment at state level. Also weather data that comes in hourly. Everything is all aligned. This, by the way, this is for entire state of Pennsylvania, and this is all aligned with the same time frame, 15 to 17. We do a lot of data processing and non-noises, and I can really speak less about. I mean, this whole effort of just doing the geocoding. You can see this is not a trivial problem. You have the starting point, the ending point right here, and something I covered in GIS classes that you really have to go to all the vertices along the road, on the curvature of the road, just to really pick up the entire segment of the work zone. And also you have to go a little bit further down and up because that's upstream and downstream. But you also need to consider the crash risks as well, right? Because if you happen to have, in Pennsylvania, there's certain rules that work zone, the buffer lane has to be, I think it's 1,500 feet versus 200 feet. I think 1,500 feet is the upstream, and then 200 feet, 250 is the downstream. And then we just have to include all that distances along the same roadway that you have the work zone, just to fully consider all the factors that we can, and also include all the crash risks. We also look at the opposite direction, but I'm not sure if you drive on the highway, oftentimes you see if there's a crash on this side, and people kind of slow down, queues up, and typically on the other side, because people are curious and they also look at the other direction, oftentimes you will see that the queue will also build up on the other side as well, even though there's no crash. So we also want to take a look at, hey, if on this side of the crash, if you see any work zone treatment on the other side, does that really affect the crash risks as well, right? And there are studies showing there's a secondary crash because the crash occurred and people kind of start to wait and see, not really starting vehicles, but they kind of slow down and, hey, what's happening? And then that fact that also could potentially create the secondary crash as well. Anyway, so we try to do as much as we can. Here's the results. I have a few more graphs to show you. Okay, stop. Sorry about talking too much. So this is, I think, just want to highlight a whole bunch of factors, and these are all the control variables you can see with all the weather conditions, the speed limit, INRIX speed data, all actual speed process, that's the INRIX data. You can see now in this case, we categorize the data into, this is all data all together, pool data, and this is based on the categorization of the AADT. You can think about the AADT, light traffic, medium traffic, and heavy traffic volume. And you can see overall, this is significant. This tells you now, if I switch the work zone presence on, yes, we can statistically show you that it actually increases the work zone. It actually increases the crash risks, but not so much on the medium or low volume traffic roadways, but it's definitely showing much higher. By the way, this factor is the log odds, so you cannot interpret that as a 60% increase. This is just if you take the exponential of this, so that gets you the change in odds. Depending on your probability, is because the work zone is always rare event. Having work zone is very, very unlikely. So that number, can also, in terms of translating to the percentage change, that may be different. But anyway, the bottom line is that you can see this is pretty significant overall, but particularly on the heavy traffic volume roads. This is what the CMF factor can play in the road. You can see this, and then this is a little bit further on top of the regression model, which is done based on the switch, and we can show how things as you add the ADT, right? The ADT is not treatment. This is simply saying, now if you treat the road on the road with categorized by ADT, which becomes continuous in this case. This is a confidence band, and the more closer to zero, it means that it's unlikely to have effect. So of course, you also want to consider how wide the band is. But over, you can see as ADT increases, you can certainly expect it to see more, the crash risk effect is more profound, right? And this is the duration. We can do the same thing. Duration overall, you can see it's not so significant, but when the duration is really short, that means if you deploy work zone only a few hours, an hour and 2 hours, and walk away, and they take all the cones and everything, it's more likely to see the crash risks comparing to a long-term work zone. Again, this is likely because the year, we have to go down to the data between the year 15 and 17, maybe the way how PennDOT deploy the work zone strategies. Could be the short-term work zone, could be, I'm only making speculations here, right? This is not just rigorously done, the investigation yet, but I'm just speculating that if it's a very short work zone, it could be a temporary permit, and the contractors can just come over, just put the cones on and get the work done and walk away. Typically, it's not set as carefully as a long-term work zone, which takes about a week, which is definitely taking more resources to set a work zone. That's just my guess. At least that's what the data tells us. We can also look into the nighttime work zone. The daytime work zone, I can tell you, it's actually the results are work zone here. But you can see the nighttime work zone, you will typically see it happens in the medium or low roadway segment. You are more likely to see crash risks on the work zone comparing to high ADT. Okay, so because again, the high ADT roadways at the night, we interpret this as you have much of space. So segment work zone does not really block the view as much, but it's actually these medium ADT volume locations that work zone setting, so it significantly increases the crash risks, but not as much as the daytime. But again, we cannot say that that because the nighttime work zone has more crash risks, then you should switch all your daytime work zone to nighttime. I think again, this is because of the way the PennDOT sets the work zone during the daytime, what is required, all the resources required to set up a work zone during daytime will be very different from what's required to set up a work zone at nighttime. So we are simply saying now, if you continue the current deployment strategy, current deployment configuration, we can tell you that if you do a work zone in this way, this ADT, right, this is the medium traffic volumes, highways, the work zone, yes, it does increase crash risks. That's something we want to further investigate how we can continue to reduce that crash. We also see that overall, yes, the work zone length, right, this time we're looking into length. We play with this number a little bit just to see what the numbers that makes most kind of sense. That's a lot of sensitivity analysis that we have done. You can see that when the work zone length is 3,000 meters, so that's a little over half a mile. Sorry, a little over.
Sean, can I ask a quick question? I'm surprised the average precipitation has a negative impact.
This
Rain reduces crash.
Yeah, because everything is correlated. So I think the weather condition, we're not really paying too much attention to the numbers, significance or not, because these are highly correlated numbers. So the significance level may not make sense in this case. Yeah, so I think the key is to look at the first row that we know because based on the design, we try to rule out all the possibilities because the RDD design. So we're hoping this significance level will tell us a lot about the causal. Yes, that's right. So we also see that this is not significant as well. Because you're just throwing so many control variables and a lot of them are related. Again, bottom line is that for long work zones, right? If you're deploying the work zone, it's a long work zone, and we switch it on. Yes, it does create more crash. So I'm skipping. This is also about the CMF factors that we can calculate for PennDOT. Right now, we're doing same thing for Maryland. I'm hoping to do same thing for California too. The last slide, this is just to tell you a little bit more. Everything I presented is results, right? But we actually did behind the scenes, we actually did a whole lot more than the work I'm showing you, because we want to make sure everything we present is solid. And the way we do this is we do robustness check tests. Sorry, I should use the plural. But we do so many tests. For example, we randomly pick the shock. We did the placebo test and temporal spatially, right? And we know right now exact the time work zone actually being deployed. But we can fake the data, fabricate the data to say, hey, what if we don't know exactly? Let's switch the time, randomly pick any of the 15 weeks that we had used for data to just randomly draw, hey, maybe I started the second week, maybe I started the 10th week. So we can do that and spatially temporally just to see, hey, the results are still giving us the same results. If it still does, it means that there was something wrong with our results, right? If it doesn't make any sense, means, hey, the data might be valid, and their results might be true. We try a lot of other things. We also try different models. By the way, the model that we use in Logit, logistic regression binary. But for these rare events with the data that's showing very clearly the over dispersion patterns, we also try other models as well. Okay, so everything just you're gonna trust me on this. We did everything. So the results still showing these are not giving us the sensible results, and thumbs up on our final conclusion. Everything I just presented. Okay, here's our two papers that we just recently published. Again, like I said, we'll continue working on getting more data and applying the methodology to other states as well. Happy to take any questions.
Yeah, I assume that when there's a crash in a work zone, there's a lawsuit involved. And I was wondering, have any of the lawsuits influenced how a work zone is designed or operated?
Yes, I'm sure it does. It's way beyond my expertise. I think every state, most of the states, I should say, PA, Maryland, Virginia, they all have its own MUTCD requirement that tells you, dictates how the contractor should put out the work zones. I'm sure the part of design is they have done some experiments. It's many decades of accumulation of like technology or experiences. I'm sure they have considered all the possibilities and to reduce the risk or maybe reduce their liability as well. Yeah, but again, this is part of how work zone is being deployed. Our work study is trying to say, hey, given the same configurations that work zone is being deployed, is there any problem? Yes or no? It increases the safety. What road, what conditions you are likely to see an increase in crash risks? Then we can investigate further.
I was gonna say, we deploy work zones every day for a township in Pittsburgh. What tips do you give after this research that we could
We haven't looked at the cranberry data yet, so we cannot tell you anything.
Oh,
this is the highway, and we did take a look at the 79 and the turnpike. But I think the arterials might be very different story. Yeah.
Yeah, we just went through flagger training and, how we set up the work zone, but it is very important, and I wanted to see, if there's any results in this study of things that we can do
We can
better.
potentially pull the data on your local arterials and run the same analysis. We cannot tell you whether you should put the flags and how to train people, but we can tell you based on current strategy or based on your current workforce, the way you deploy the work zone, yes or no, this increases crash risk statistically or not.
And we do follow the PennDOT, setup, so,
Yes.
yeah, if they can incorporate this data, that in turn.
I think that
help us.
the work zone data, we have to go to the central office to request, but we can, yes, the data is there,
Yeah, it will impact even what we do.
yes.
I have another maybe clarifying question.
Yep.
I didn't quite understand the results. I'm wondering, is it because the work zone caused the crash, or is it because the work zone has increased the traffic, then the traffic caused the crash? Do we differentiate that?
So that's a great question. The way we try to do this is try to separate the fact that the traffic without work zone, the traffic, there are heavy traffic, the low traffic, the medium traffic itself, without impact the work zone, will create some kind of crash. That certainly it's the part of the portion of the influences that the crash that you see will be attributed to the fact that there are people, right, using the road. I think another set is like you mentioned, this is if you create a work zone, a certain type of road, type A road, let's say, that increases the traffic and changes the traffic driving behavior. So that's all, everything, in that category will be associated with that treatment. So you cannot separate these two, right? So if you treat the road, you give this road a shock. So everything that will come, the change in behavior, change in whatever, will come with the deploying the work zone. So I think altogether they will attribute to the crash risk another way. So we just try to separate these two in a way that the traffic volume will impact the work zone crash in two ways. One is direct way, because with or without work zone, I'm impacting the crash risk in this X%. And the other percentage is coming from, because I deploy the work zone that change the travel pattern and change the congestion level, change the driving behavior. So because the fact that you are putting 1 mile long buffer zone or whichever you put the cones, then that will be another factor. So we try to eliminate, so to extract the factor from, separate the factor from the latter, of the latter from the former.
So can I understand maybe for future, if we want to say increase the work zone safety, we are targeting at how we can maybe design the work zone to make it minimize the traffic or volume change, or maybe.
That could be one strategy, but again, this study cannot tell you the answer how to design the work zone, right? This is only telling you, based on the current work zone setting, yes or no, it changes, and what conditions. And then if you see, hey, this is changing, and then you probably want to look into data just to look at the police narratives, and there's a lot of other things that you can look into how to improve the work zone. And then maybe, and practically, in a more practical sense, you probably, after you change say this itself it measures the impact of a shock. So think about it this way. So next time, maybe a year from now, let's say PennDOT changed the way they set up the work zone. Say right now it's 1,500 feet of buffer zone. Maybe they want to extend it to 2,500 zone. And then after they mandate this change, let's see, maybe let it play out for 6 months or so, and you collect more data, and then we can rerun this study to show, hey, the shock, the fact that you change the work zone mandated requirements, does that impact the work zone safety risks? Yes or no, right? Then we can do that. But I think everything we measure is whether how effective it is a treatment or shock, rather than telling you an optimization of the configurations.
Thank you so much for sharing your research, and everyone, thank you for attending today. As I mentioned earlier, a recording of today's session will be posted on the What's Happening page of the Safety 21 website. If you're a student really interested in getting more involved in transportation, feel free to talk to me, Grant, or Shubham about Transportation Club. And our next Smart Safety Connection seminar will be on Friday, March 8th, where we'll be doing a watch party for Professor Sheng from Morgan State University. So keep an eye out for that invitation in your email. Thank you.